how that TCP connection gets set up in the first place. When a client is sending an initial connection request to the server, so this is where the server has done a listen and the client is doing a connect, that connection starts out with a packet that has the send flag set to 1. So that flag means this is a packet intended to create a new connection, which means create a new socket on the server side. Also, you would think that sequence number should be 0 here because the client hasn't sent any data. But actually, the client picks a random number C to use as a starting point instead. And the reason for this is that it provides a small bit of security. It makes it slightly harder for some other actor on the network to send TCP packets that the server misinterprets as being from the actual client. In any case, if the server receives that connection request, when it replies, it's going to use that same C as its acknowledgement, though it's actually going to bump it up by 1, and in a way treating a synthesized request as having 1 byte of data, even though it's not actually there. The server similarly is going to generate a random S for its initial sequence number, just like the client picked C. And when the server is granting the request, it'll keep this send flag set. In this case, since it's from the server, then that's not requesting a new connection, it's granting the completion of the connection that was requested before. And after the client gets that, then it can start communicating as in the SETI state. It can acknowledge that it has received the connection from the server by bumping S by 1, again, just because that's how we get started, even though there was no data. And then at this point, the client can start sending data, and future sequence numbers will go up by the amount that was in the data. Meanwhile, the send flag is turned off because we're not trying to create the new connection anymore. We are going with the connection that is created. Meanwhile, the send flag is set to 0 because we're not creating the connection anymore. We are now in the middle part of the protocol where the two sides exchange data, including this data that is in the third packet of the overall sequence. So you can see how, to even get started in TCP, we need 2 packets going back and forth before we can, on the third packet, finally start sending data. Again, the way this starts is that the server uses listen to create a listening port, and then the client, at some time later, uses connect to send that connection request. And at this point, after the connection is granted, then that's where an accept will return the socket from the OS. Or at least that's the way things used to work. These days, actually, the connection will not be available on the server host until the client actually starts sending data. And this is another kind of security measure, because it turns out that it's easy to flood a server by sending send packets to it and then never paying attention to the results sent by the server. So it turns out to be very cheap to send these packets, but then the server has to do a bunch of work to create a socket connection. And a malicious sender of those packets maybe doesn't have any sockets at all, it's just making up these meaningless packets, forcing the server to do work to create the connection and to compute the results here and send it back. And this was a problem 20 years ago or so. So the solution is that no socket is actually allocated until the client manages to reply a second time, and that's showing that it's putting in some work into keeping track of its packets and replying. The way that the server is able to do this is it doesn't actually create a socket here. It picks the S that it sends back in a way that encodes the client's identity and the client's sequence number C. And so when the server gets this third packet here, it can see that S and C and the client's address and its own address, that these are all consistent with each other, and so real communication is going on. So this is the point where the accept will actually happen now. So it happens that these sequence numbers that were picked at random as a very lightweight kind of security provided a more interesting kind of security when this use was found for it.